The next rule or property of logarithm is the zero rule, which tells us that if we take the logarithm of 1 to whatever would be base, as long as it follows the condition for a base of logarithm, we have an equivalent to 0. Hence, it's called zero rule. So we're going to show that from here, we will reach a 0 value. Now you can try this in your calculators with any value of b, as long as, again, it fits the definition for logarithms. It will always be equal to 0. But we're going to show this here analytically. So here would be the proof. Okay. So we are going to let, okay, I'm just going to show you the proof here. The logarithm of 1 to the base b equal to any variable x. Since we are proving this, we would like to show that this x value later on is just equal to 0. Again, you can try just simply manipulating this logarithm, or again, your calculators, and it will give you really a value of 0, but we're going to show it here analytically. To do this, don't forget that if we have a logarithm of, say, a to the base b, which is equal to a certain variable y, let's just use y to differentiate it with x here, we can transform this into an equivalent exponential equation where we take the base b here, okay, y would be its exponent, and your a coefficient is its equivalent. So this is a transformation from logarithms to exponential equation and vice versa. Now from here, again, our goal is to show that x is 0. So applying this would be our b, okay? Our b here, that would be our base. Our y, which is this x here, is equal to our expression here, 1. Okay? Now, from here, when do we get an exponentiation equal to 1? That actually means, according to laws of exponents, we can always get 1 if the exponent of a certain expression, x, is equal to 0. Okay? Because if x is equal to 0, whatever with the value of b, it would be equal to 1. This shows that the value of x, which is this expression, the logarithm of 1 to the base b, is equal to 0, and it proves the 0 rule here. Now, if you're not satisfied with this, there's also another method to do this. We will have b to the power of x is equal to, if we have 1, and you would like to use the property of equivalent exponents, where we come up with an exponentiation of the same base, you have here b. Of course, we can only get 1 if its exponent is 0, because b to the power of 0 is just 1. That's 1 here. So, again, according to the property of equivalent exponents, as we have the same bases, the exponents must also be the same. So, this is also another way to improving this 0 rule. Or, the last step is simply applying this transformation to this here as your proof. You will have your base b, this is your base b. This would be your exponent 0, and that's equal to your value here, 1, which is true as you, again, you express b raised to 0, or any value raised to 0 is equal to 1. But we're going to stick with this first portion, as again, we assumed this certain expression as x, just for analytical reasoning of this rule. This is Properties, Laws, and Theorems. Please subscribe now.